We're going to continue with factoring in lesson 5.4, and you can see that I've written some patterns that you're going to need to be familiar with for this lesson. So stop the video and write these down so that you have them. You probably should write them on a piece of notebook paper that you can keep in your notes, because we're going to be using this for all of these patterns for chapter 5. I've also written down the cubes. If you don't have those cubes memorized, you will want to do that so that you can work quickly through these and recognize them quickly. The difference of squares, this first pattern we've used a lot in the past. That one should look really familiar. The difference of two cubes and the cube, oh, not the difference of two cubes. Actually, that's new to this lesson. The cube of a binomial. Those two, you've got two different ones, whether there's a plus sign or a minus sign in the parentheses. We used these in lesson 5.3. So these are brand new to you as well. There are two of them based on the sum, whether it's a sum or a difference. The new ones for this lesson are a sum of two cubes and the difference of two cubes. So I wanted to write all this out in one spot for you so that you can see the difference between the sum of two cubes right here. This is a cubed plus b cubed. That's very different than coming down here to this cube of a binomial where you have a plus b in parentheses. So the addition is happening first, and then you're taking the sum of those and you're cubing that. So you're going to want to watch out for whether there's parentheses or not. This is a sum. We're adding two different cubes, a cube of A and a cube of B. This, we are, down here, we are adding A and B, and we're cubing that binomial. And this one, we are subtracting A and B, and we're cubing the difference. All right, so that's the difference between these two new ones in 5.4 and the one we just learned in 5.3. Now, how we use these. If we go over to number 1, we can see that we have definitely have an a value that's cubed. This is x cubed. So our a value here is simply x. Then we go to our b, and we can actually see as well, if you're familiar with these cubes over here at all, you can see that 125 right here is 5 cubed. So we have a b value of 5. So now we can go in and find this pattern over here. This is a sum of two cubes. We have a cubed plus b cubed. All right, there's no parentheses in this problem 1. So we know that it's a sum of two cubes, not a cube of a binomial down here. So now we're going to follow this pattern over here of a sum of two cubes. We're just going to write in. I'm going to do it right here because I have more room. So x cubed plus 125, and we're going to follow this pattern. It's going to equal a plus b, which is x plus 5. Okay, I'm getting that from right here. And then I'm going to follow the rest of it. A squared, which is going to be x squared, minus a times b. So that would technically be x5. I'm going to reverse it because we always put our coefficient first. And then plus b squared. Well, 5 squared is 25. And so this is our answer to that, to how to factor that cube. We can do the same thing in number 2. In number 2, we can see that we have y cubed is a perfect cube. So our a value is y in this one. And 8 is a cube. That's over here. That's the cube of 2. So b is 2. We have a difference sign. We have a minus sign in there. So we're going to come over here and we're going to pull out the difference of two cubes pattern now instead. So this one right here. All right, it's very different from the cube of a binomial with a subtraction sign in the middle. All right, there are no parentheses over here in that y cubed minus 8. So we're just following the pattern. I'm going to rewrite out my original equation, and then I'm going to follow the pattern. It says that a subtracts with b, and then I'm going to square a. I'm going to multiply a and b together to give me 2y, and then I'm going to square b to give me 4. Okay, the only difference here in this pattern you can see is that this one has a minus sign in that first binomial, instead of the sum has an addition sign in that first binomial. Right, when we go down to number 5, nothing really pops out at us. That 2w cubed is not a cube, and 54, you can scan down your list here, that is not a cube. So we're going to go then to our next step, which is if we can't do anything really, we're going to always look to see if we can factor a GCF out. And in this case, we can factor out a 2. So once I've done that, you can see that now I have a perfect square in that binomial. All right, w cubed is a perfect square, and 27, I'm sorry, is a cube, and 27 is a cube. Okay, so my a value for number 5, after I factored the 2 out, is going to be w, and then my b value is going to be 3. And I'm getting that from this list over here. So I'm going to just rewrite that too. Okay, we're just dropping it down. It's just going to kind of follow us through each line of work. This is w cubed plus 27. Now I know there are parentheses here, but the parentheses are only there because I pulled that 2 out. This is still a cube plus another cube. We're not adding something in together in here and then cubing the whole thing. So this is still a difference of 2 cubes. We're still looking at this pattern here. If it weren't, then we would have the cubed sign would be out here, like it is on this right here, on that pattern, the cube of a binomial. But it's not there. That's not where it is. And so even though there is a parentheses there, that parentheses is there for a different reason. So we're going to follow this pattern for difference of 2 cubes. So I'm going to write a minus b, so w minus 3. My a squared will be w squared plus, I'm multiplying a and b up here for my middle term, so that's going to be 3w. And then my last term is going to be b squared, which would be 9. Right? And so this is factored now, that cubic polynomial. So now on 7, 8, and 9, they want us to factor the polynomial by grouping. We have done this because of when we worked on factoring in the last chapter when a is not 1. This was one of our steps when we did that. So we're going to group the first 2 together, and we'll group the last 2 together. Okay, actually that parentheses should be around the plus sign there, technically. And we're going to pull the GCF out of the first group, which is r squared. That leaves us with r minus 3. And then the GCF with the second 2 is positive 6, r minus 3. All right, then we've got, in each of these terms, we've got a binomial that's common to both. So I'm going to take the r minus 3 out of the first term. I end up with r squared. Take it out of the second term, and we end up with this right here. We'll do the same thing on number 8. Group the first 2, group the last 2, pull out the GCF. Okay, our binomials match, so we're going to pull each of them out and write out what we're left over with, and there we have that factored. Same thing on 9. Group them off, pull out the GCF. Our binomials match. Remember, if you had pulled out a positive 9 only, the signs on the C plus 4 would be different. So then that would just clue you in your binomials don't match, so you need to go back and pull out that negative sign. We're going to pull the binomial out of each term, and we'll end up with that. Now, we're not actually done on this one because this right here, this c squared minus 9, hopefully that looks familiar as a difference of squares. So that's why I have that written up here at the top. A squared minus b squared follows this pattern, and this we've used for a while now. All right, so we're just going to follow that pattern because we've got a c squared, and the a value is c there, and then 9 is 3 squared. So we're just going to follow that pattern then. So I'm just going to rewrite the c plus 4. We can't do anything else with that. That's as simple as it gets. And we're going to rewrite c squared as c minus 3 times c plus 3. And that's just that special pattern that those polynomials that have a difference of squares in them follow. Now in 13 and 14, we are going to use the difference of squares again. So I've rewritten that pattern here. They ask us to factor that polynomial, and while it might not be obvious right away, x to the fourth is actually x squared squared. So it is a perfect square as well, because I could rewrite x to the fourth as x squared raised to the second power. All right. So that means that according to our difference of squares, and 36 is a perfect square. That's 6 squared. So it follows this difference of squares pattern. Our a then is x squared, while our b is 6. And we have a subtraction sign in there. So we can just write that original problem, x to the fourth minus 36 is going to follow this pattern of a minus b times a plus b. Oh, and that's supposed to be a 6, not a b. Right here. The same thing on number 14. So if you look at that c to the fourth, that c to the fourth really has an a squared value in it. That's really c squared squared. So c to the fourth is actually a perfect square. We know 81 is a perfect square. That would be 9. So that makes your a value here c squared, your b value 9. There's a subtraction sign there, so it follows this pattern for difference of squares. So c to the fourth minus 81 equals c squared minus 9 times c squared plus 9. Now, we're not actually done yet, because this binomial right here, the c squared minus 9, is actually another difference of squares. So c squared is a perfect square. We have a subtraction sign, and then 9 is a perfect square. So our a value is c, our b value is 3. So if we continue on with factoring this, we'd end up with c minus 3 times c plus 3. This we can't do anything with. This is not a difference of squares because there's an addition sign here. So we just rewrite it. That addition sign changes everything. We can only keep factoring because that is a minus sign there. All right, now on number 15, this one right here, we have an a value of 1, and we have negative 20 here as our constant. And we've got 3 terms, so we have a trinomial. We're going to factor this the same way we do when we actually have just a quadratic. Remember, this isn't technically a quadratic because it is x to the fourth, but we can write it in terms of quadratic form. So this is how we do this. We're going to start the same way that we started when we factored, say, like, for example, what you would be used to seeing is x squared plus x minus 20. You would be used to the exponents not being as high. The lead coefficient would have an exponent of 2, and then you'd have a 1. Here we just have raised it to a 4 and a 2. But we're going to start this the same way. We're going to find factors of negative 20 that add to 1, just like we would have over here. So factors of negative 20 that add to 1 would be 5 and negative 4. So now what we're going to do is write out our binomials. Okay, and over here, if it were just an x squared, this would have been really easy. You would just write x plus 5 and x minus 4. The reason you wrote x at the beginning of each binomial was because this is an x squared and you were splitting those x's up. So if you can remember that y, it was just an x here and one x there, because if you multiply those together, you get x squared, then hopefully it makes sense that instead of writing x in the binomials here, we're going to write x squared and then the other x squared over here. Because if you put the two of those together with multiplication, if you FOIL, your first terms would come out to be x to the fourth, which is what we want. And then you just fill in the factors of 20. All right, now, unfortunately, we're not done with it because we now have to look for a difference of squares, and we see it right here. X squared is a square, and 4 is a square, 2 squared, right? There's a subtraction sign in between them, so we have to rewrite this first binomial. We can't do anything with that. And then we're going to write this out as a product of, as a difference of two squares, which takes that pattern a minus b times a plus b. And now we are done factoring this. All right, number 16. Now we don't have a lead coefficient of 6. Of 1. We do have a lead coefficient of 6. So we've got to follow those steps for when our lead coefficient, when our a does not equal 1. So if you remember, we multiplied the first and the last, and got negative 24, and then we looked for factors of negative 24 that would add to negative 5. That you're still multiplying the first and the last and adding to that middle term. So for negative 24, we could have and I'm just going to write down without negative signs, 212, and we've got 3, 8 as factors. And one of them needs to be negative, so we can see right here that we're going to need these two, and we can make that one negative, and that's what will work. So then we're going to follow those steps where we rewrite the first term. We rewrite that middle term as a sum of the 3 and the negative 8. Okay, now you've got to watch your exponent, because this is a y cubed, not just a y. So we're going to say 3y cubed minus 8y cubed. All right, because 3y cubed minus 8y cubed will add up to negative 5y cubed. All right, so we're just looking at what that term is, what the variable is, and the exponent's raised to. And then I'm going to just drop down that last term. All right, now we're going to continue our factoring by grouping, same as we did with quadratics. Okay, to group them off, it looks like we're going to get out the GCF easily from each of them. So it looks like we factored out correctly. Right, you'll end up with the 2y cubed here and 1 there. And then we're going to factor out a negative 4 here so that we end up with a 2y cubed and another positive 1. So that's good because our binomials match. So we'll factor out the binomial from each of those terms and write what is left over. At this point, we don't have any difference of squares. Okay, the only one that's a difference is this right here. 4 is a square, but 3y cubed is not a square, and it cannot be written as a square. Okay, it's not an x to the 4. Or sorry, I'm sorry, it's not a y to the 4th that we could rewrite as y to the 2nd squared. It can't even be rewritten. So this is our final answer here. All right, on 17 and 19, they say factor the polynomial completely. We're just doing more of what we've already done. Here we have a difference of squares. We've got that difference, that subtraction sign in there, so we've got to look. X to the 6th can be written as x to the 3rd squared. Okay, and then we know that 4 is the square of 2. So our a value becomes this x cubed right here, and our b value is 2. So we're going to follow the pattern once again for difference of squares, which says you take your a and you subtract your b, and then you do that again, but you add your b. All right. Now this can't. The only thing we really need to look for is like, is there any other factoring we can do? We can't do anything else. This has a subtraction sign in it, but these are not perfect squares. So because they're not, we can't simplify anymore. So that's our final answer there. On number 19, again, we don't have a difference of squares. Now 81 is a square, but 24q to the third is not. So the next thing we're going to look at is like that one that we started off with up at the top of the page. We're going to take out a GCF. So we're going to look and see. It looks like we can pull 3 out of both. And we'll end up with this right here. All right. So now what we need to do is see if we can factor that 8q cubed minus 27. Now, if you go back to your notes and you see where you wrote down those sum of 2 cubes and the difference of 2 cubes, this is the difference of 2 cubes, and I'm pulling this one out to rewrite because we have a difference problem. We have a subtraction sign in that 8 q cubed minus 27. So 8 is a perfect cube. That's 2 cubed. Q is a cube. I'm sorry, q cubed is a cube. Cube is just q. So our a value here becomes 2q. Because if you raise 2q to the third power, you get a 8q cubed. All right, then that 27 that we have is also a cube. It's 3 cubed. So our b value becomes 3. So if I come over here, I can't forget about this 3 that GCF I pulled out. So I'm going to rewrite that right now, and then I'm going to follow this pattern with the rest of it. I'm going to say 2q minus 3 times 2q squared. So I'm actually gonna put that in a little squared thing right there, so I can come back and do that later. Then I have my a, which is 2q, times my b, which is 3, plus 3 squared, which is 9. All right, now I need to come down here and do some cleanup. 2q squared, so I'm squaring that 2 to make 4. I'm squaring that q to make q squared, multiplying these together, and this right here. All right, and that, thankfully, is our final answer. All right, number 30 is putting all of this together. They have given us a diagram showing us the length. This is the outer length of that planter box. This is the outer width of the planter box, and this is the outer height. Okay, and so what I mean by the outer measurements is if you took a measuring tape and you actually measured, where it meets the sidewalk. But you can see that there's a thickness to this wall, and they told you in the problem that that thickness is 1 foot. So right here is 1 foot, right here is 1 foot. I mean, everywhere around this planter, you've got this thick 1 foot wall. They told us in the problem that they want us to solve for the outer dimensions. So they want us to tell them the outer length, the outer width, and the outer height. But the information they give us is that the planter itself will hold 4 cubic feet of dirt inside of that inner area. All right, so this is really similar to those picture problems we did back in the last chapter. It's just that now we've added the dimension of height, okay? Whereas with the picture, we were just using length and width. So we're going to use what we know about the outer length, width, and height, and the fact that we know this wall is 1 foot thick to write expressions for the interior length, width, and height. So the insides that are actually touching the dirt. All right, so your interior length then is going to equal this 6x measurement that's on the outside. However, it's a foot shorter than the outside length because of the thickness of that wall. So we have to say 6x, but we have to take 2 feet away, 1 foot on each side. All right. The interior width, we're going to do the same thing. The outer measurement is 3x. However, we have to account for the thickness of this wall in here. Once again, 1 foot on each side is going to be kind of taken away from it. So we're going to subtract by 2. All right, that will give us the width on the inside that the dirt is actually touching. And then we'll do the same thing for the interior height. That would be x. Now, in this case, they told us in the problem that this thing is sitting on a sidewalk, and so they didn't build a bottom onto it. So there's no bottom, it's actually just open. If it weren't sitting on the sidewalk, the dirt would just fall through. So because they told us that, that means that we only have to account for a 1 foot difference on the height, because there isn't that 1 foot thickness on the bottom to account for. So in this one, we're just going to say, actually, I'm sorry, we don't have to account for any of it, because it is completely missing a bottom, and of course it doesn't have a top. If it had a top, you couldn't fill it with dirt. So the height for the interior is actually the same as it is for the outer, okay, because you don't have a bottom that's a foot thick, and you don't have a top that's a foot thick. All right, so now that we've got all that together, we need to think about our volume means length times width times height. That's our formula. They told us the volume of the dirt that this will hold. As long as we're using our interior measurements, we can multiply those together and say it's going to be 4 cubic feet, because that's how much this dirt is being filled up in that planter, and we're just assuming they're filling it all the way to the top. All right, so we're going to take our interior length, 6x minus 2, the width, 3x minus 2, and multiply that by the height of x. All right, just to save a little bit of time, I just paused the video and went ahead and did FOIL on the first 2 binomials and got this line right here. And then I moved down to the last line there just by combining the negative 12x and the negative 6x. All right, so now we end up with this trinomial, and we still have to multiply by the height, that height of x. And so I'm going to go through and distribute that x to each of those terms. All right, I just distributed that x, and so now what we're going to do is set this whole thing equal to 0. Okay, so I'm going to do that by subtracting 4 from both sides, and when I do that, I can actually drop these parentheses, because the parentheses on the right hand side were only there because I had multiplication to do. So I really didn't even need to write those. Everything now is addition and subtraction. So we can just rewrite, and then that'll be a minus 4 on that side. And now we have 4 terms. So we're going to follow our steps for factoring when we have 4 terms, which is grouping the 2 in the front, the 2 at the end, and then pulling out the GCF. Okay, and thankfully we get binomials that match. I'm going to come up here and I'm going to factor out the binomial from each of those expressions, and I'm going to end up with this right here. All right, now from here we can see that we're not quite done. We can factor a GCF out of the 18x squared plus 4. So we're going to go ahead and do that. I'm going to kind of switch sides here, and I'm going to bump that x minus 1 down and go ahead and put our 2 that's going to come out of the 18 and the 4. That's going to leave me with 9x squared plus 2, and then I'll have that x minus 1 there at the end. All right, so Now at this point we are factored as far as we can go, but so we can take those binomials, set them equal to 0. Remember, I can ignore the 2 because 0 does not equal 2. So we just ignore anything that doesn't have a variable in it. Okay, and then at this point, we end up with 9x squared equals negative 2. So we end up with x squared equals negative 2 over 9. And of course we know we can take, you now have enough information to take the square root of x squared and take the square root of a negative number. But we're not going to get a real solution if that happens, right? If we're going to take the square root of a negative number, that means we have to pull I out. It's an imaginary number. So we don't want to do that. That's not going to make sense with our measurements up there. So we're going to throw this solution out and we're going to keep this one. So x equals 1. Now, you're not done though, because the actual question said what should the outer dimensions of the planter be? So you need to go back and stick the 1 in, evaluate each of these at x of 1. So that would mean the length is 6 feet, the width is 3 feet, and the height is 1 foot. So you could write it like that, or you could say 6 feet by 3 feet by 1 foot. Okay, either way would work.